Jaws and claws. This jaw can snap a human femur in half with less effort than you'd use to bite an apple. But here's what will blow your mind. This isn't actually a dog. Meet the hyena, nature's ultimate contradiction. It grooms itself like your house cat, hunts in packs like wolves, but has a bite force that puts lions to shame. But here's the kicker. Everything you think you know about hyenas is probably wrong. Despite their dog-like appearance and pack-hunting behavior, hyenas are actually more closely related to cats than any canine species. Genetically, hyenas belong to the feliform suborder, the same evolutionary branch that gave us domestic cats, lions, and mongooses. Watch this behavior that proves their feline heritage. Notice how they position their limbs to groom their rear end, a distinctly cat-like behavior that no dog species exhibits. They also scent mark their territory using anal gland secretions, just like their feliform relatives, rather than their leg-lifting urination typical of canids. For millions of years, these remarkable animals have thrived across the harsh African plains, developing extraordinary adaptations that allow them to survive where other predators fail. Today, we'll explore how this cat relative evolved into one of Africa's most successful predators, and the remarkable strategies they've developed to dominate one of Earth's most challenging environments. To understand the modern hyena, we must journey back over 20 million years to the Miocene epoch. During this period, small civet-like ancestors called Piloviverops roamed the forests of ancient Eurasia. These early creatures belonged to a group called feliforms, the same evolutionary branch that would eventually give rise to cats, mongooses, and civets. Over millions of years, these ancestors diverged into two distinct lineages. One branch evolved into the dog-like running hyenas, agile pursuit predators that resembled modern-day African wild dogs. The other branch developed into the bone-crushing hyenas we know today. The running hyenas, despite their initial success, eventually went extinct around 5 to 7 million years ago, leaving only the aardwolf as their modern representative. The bone-crushing lineage, however, thrived and diversified into the three species we see today: the spotted hyena, brown hyena, and striped hyena. This evolutionary path explains why hyenas exhibit such a fascinating mix of characteristics. Genetically, they remain feliforms, sharing more DNA with cats than dogs. Yet their body structure, hunting behavior, and locomotion have evolved to resemble canids, a perfect example of convergent evolution. The spotted hyena's body is a masterpiece of evolutionary engineering, perfectly adapted for life on the African plains. Their distinctive sloping profile isn't just for show. It's a biomechanical advantage. The higher shoulders and powerful forequarters provide the leverage needed for their bone-crushing bite, while their lighter hindquarters reduce energy expenditure during long-distance travel. Their legs tell an interesting story of adaptation. Unlike their cat relatives, hyenas have developed non-retractable claws and digitigrade locomotion, walking on their toes like dogs. This adaptation allows them to maintain traction on varied terrain and achieve remarkable endurance during hunts that can last for hours. But perhaps their most remarkable adaptation is their jaw structure. The hyena's skull is massively robust, with a shortened face that maximizes bite force through mechanical advantage. Their carnassial teeth, the blade-like molars used for shearing, are positioned far back in the jaw, creating a nutcracker effect that can pulverize bones other predators can't even crack. This isn't just about brute force. The hyena's digestive system is co-evolved with their bone-crushing ability. Their stomach acid is significantly more acidic than other carnivores, allowing them to break down and extract nutrients from bone calcium and marrow that would be indigestible to other animals. This adaptation provides hyenas with a crucial advantage during the dry season when prey is scarce. While other predators struggle to find fresh meat, hyenas can return to old carcasses and extract nutrients from skeletal remains that have been picked clean by other scavengers. Surviving in the African wilderness requires exceptional sensory capabilities, and hyenas have evolved some of the most sophisticated sensory systems in the animal kingdom. Their olfactory system is particularly remarkable. Hyenas possess over 800 functional olfactory receptor genes, compared to humans' mere 350. This extraordinary sense of smell allows them to detect carrion from distances exceeding 6 miles, even when it's buried or hidden. During the dry season, this ability can mean the difference between life and death. Their hearing is equally impressive. Hyenas can detect infrasonic frequencies, sounds below the range of human hearing. This allows them to eavesdrop on elephant communications and potentially detect geological activity that might indicate water sources or prey movement patterns. Their vision, while not as acute as some predators, is well adapted for their crepuscular lifestyle. Like many African predators, hyenas have a tapetum lucidum, a reflective layer behind the retina that enhances their night vision, giving them that characteristic eye shine in darkness. The African savanna presents extreme challenges that test every aspect of a hyena's biology. During the wet season, the plains transform into a lush paradise teeming with prey. Massive herds of wildebeest, zebra, and antelope provide abundant hunting opportunities, but this abundance is temporary. When the dry season arrives, temperatures can exceed 120 degrees Fahrenheit. Water sources disappear, and prey animals migrate hundreds of miles in search of fresh grazing. This is when the hyena's adaptations truly shine. Hyenas have developed several strategies for thermoregulation. They're primarily nocturnal during hot periods, reducing activity during peak temperatures. Their large ears help dissipate heat, and they can lower their metabolic rate during food shortages, essentially entering a state similar to hibernation while remaining active. Water conservation is another critical adaptation. Hyenas can obtain much of their water requirements from their prey, and their kidneys are highly efficient at concentrating urine to minimize water loss. When water sources are available, they've been observed traveling over 50 miles in a single night to reach them. Their social structure also serves as a survival mechanism. During harsh periods, clan members share information about resource locations. The complex communication system we'll explore includes specific calls that indicate the discovery of food or water sources. Contrary to popular belief, spotted hyenas are primarily hunters, not scavengers. Research has shown that they hunt and kill up to 95% of their own food. Their hunting strategy is a masterclass in endurance and cooperation. A typical hunt begins at dusk when the clan disperses across their territory. Hyenas can maintain speeds of 35 miles per hour for extended periods, an endurance that few prey animals can match. They use a technique called coursing, pursuing prey over long distances until exhaustion forces the animal to slow down. What makes hyena hunting particularly effective is their intelligence and adaptability. They've been observed using sophisticated strategies like relay hunting, where clan members position themselves at strategic points to intercept fleeing prey. They can also adjust their tactics based on prey species, using stealth for smaller animals and pack coordination for larger prey like buffalo or young elephants. Their bone-crushing ability provides another survival advantage. While lions and leopards abandon carcasses once the soft tissue is consumed, hyenas can continue feeding for days. They consume everything: bones, hooves, hide, and even horns. This efficiency means that a single kill can sustain clan members much longer than it would other predators. During the lean dry season, this ability becomes crucial. When fresh kills are rare, hyenas can return to old kill sites and extract nutrients from remains that are weeks old. Their powerful immune systems protect them from the bacteria and toxins that would sicken other animals. Hyena society is among the most complex social structures in the animal kingdom. Spotted hyena clans can contain up to 80 individuals, organized in a strict matriarchal hierarchy that determines access to food, mating opportunities, and territory. The matriarchal system provides stability that's crucial for survival. Female hyenas are typically 10% larger than males and maintain strict hierarchies that are passed down through generations. This system ensures efficient resource allocation and reduces internal conflict that could weaken the clan's ability to compete with other predators. This social complexity serves crucial survival functions. In the harsh African environment, cooperation is essential. Clan members share information about resource locations, coordinate hunts for large prey, and collectively defend territories that can span over 1,000 square kilometers. The famous hyena laugh is actually part of a sophisticated communication system. Researchers have identified over 11 distinct vocalizations, each carrying specific information. The laugh, or giggle, typically indicates submission or excitement, but the pitch, duration, and frequency convey individual identity, age, and social status. Their scent marking behavior is equally complex. Hyenas have specialized anal glands that produce a paste-like secretion containing chemical information about identity, reproductive status, and social rank. These scent marks can remain detectable for weeks, creating a chemical communication network across their territory. The spotted hyena represents one of evolution's most successful experiments in adaptation. Through millions of years of evolution, they've developed extraordinary physical capabilities, complex social structures, and remarkable survival strategies that have allowed them to thrive in one of the Earth's most challenging environments. Their story teaches us about resilience, cooperation, and the intricate connections that sustain ecosystems. These remarkable animals have survived ice ages, climate shifts, and human expansion through their incredible adaptability and intelligence. Understanding and protecting hyenas isn't just about preserving a single species. It's about maintaining the delicate balance of African ecosystems that support countless other forms of life. As we continue to study these remarkable animals, we discover that there's still much to learn about their complex world and their crucial role in maintaining the wild Africa we all want to preserve.